We need to be able to look at an ionic compound and know if it's a strong electrolyte or not. And the reason we need to be able to do this is because we need to follow what's happening to the ions in order to understand the chemical reactions, or if a chemical reaction is happening at all. So how do we know? Well, first of all, if an ionic compound is water soluble, then it's a strong electrolyte. That's why we need to be able to look and tell if something is water soluble. If you don't know it's water soluble, but it shows that symbol, AQ, then we know it's dissolved in water and we know it's water soluble. Okay. The others that we may see as strong electrolytes are the strong acids. And we're going to need to memorize those, and also the strong bases. The bases are ionic compounds. The acids don't look ionic because they're nonmetals, all nonmetals, but when you put them in water, they often act ionic. That's what makes them acids. So we'll have to memorize our strong acids and our strong bases. I'm going to start with the acids, and there's some that you know, you've heard the names because they're pretty common. Hydrochloric acid is one that's pretty common. Another one is sulfuric acid. We may know that name and formula. And another common one is nitric acid. Okay, and then I'm going to add some that are kind of related to this one. Chlorine is a halogen. And so two others that are based on that, on being a halogen, are hydrobromic acid and hydroiodic acid. So the second column from the right on the periodic table is the halogens. And on that list, it starts with fluorine at the top. So note that, that HF is not one of them, but the other halogen-based acids are. Okay, and we're not quite done with our list. We also have HClO3, that's chloric acid, and HClO4, that looks like an E, that's perchloric acid. And that's all 7 of them. So if you see a different acid, like for example, oops, that doesn't need a 2 there. For example, this is acetic acid. I don't have to know whether it's strong or not, or I mean, I know that it's not strong because it's not one of these 7. So it is not strong. Okay, and then for the bases, we're going to use group 1 and 2. Group 1 and 2 metals are the first 2 columns on the left on the periodic table. If you look under lithium and under beryllium, those. So group 1 and 2 hydroxides, except beryllium hydroxide and magnesium hydroxide. Sometimes you'll see lists of strong bases where magnesium will be considered strong. It really is kind of on a borderline, but for our purposes, we're going to consider those not strong, so I'm going to cross them out. So not those, but any other, erase this, any other hydroxide made from those group 1 or 2 metals. Okay, we're going to do some practice. For each of these, determine which one is strong. And this is how it's going to be when we start writing equations. We'll often have 2, and we'll decide which one is a strong electrolyte and which one is not. So we kind of look for all of those clues that we have. First, I don't have a rule for silver iodide. We didn't learn a rule for that, but we do have a rule for calcium hydroxide. It's a strong electrolyte because it is a strong base. Next to, this one is one of our strong acids. Next to, I'm looking for those hints. HF is one of those halogen acids, but if you remember, this is the only one that is not strong. This one has acetate, and acetate is one of our ions that only forms water-soluble compounds. So that one is, if it's ionic, which that is, and it's water-soluble, then it's a strong electrolyte. Next, I see potassium. Again, it is one of our, the potassium ion is one of our ions that only forms water-soluble compounds. Next is this nitrate. I don't have a rule, or I don't know a rule for copper phosphate, but I see the nitrate, so that's how I know. Nitrate only forms water-soluble compounds. And then the last one, I don't know a rule for silver chloride. Actually, that's a common one I do know, and it's not water-soluble. But I also know this one is, even though I didn't teach you a rule for copper chloride, copper 2 chloride, it has that symbol AQ, so we know it's dissolved in water.